Okay, welcome class 9 student. As you know, we are discussing motion, and in motion we had discussed about distance, displacement, speed and velocity and their definition. Now we will do some numericals based on it. So first numerical for you. Let's suppose any car driver, this is given for homework in some class I think. Any car driver travel between two stations by 60 km per hour. Note down the question. Any car driver travel between two stations, let's suppose Rihanagar and Shaktinagar. He is going from Rihanagar to Shaktinagar by maintaining how much velocity? 60 km per hour, and return back by 40 km per hour. Velocities are different. He is going from A to B by 60 km per hour and coming back by 40 km per hour. Let's suppose this velocity is V1 and this velocity is what? V2. I asked, no doubt, this is the variable velocity. Already we taught you. This is the variable velocity, and I asked what will be the average velocity. So don't go simply 60 plus 40 divided by 2. Don't do as like this. This is the wrong answer. Okay. So first A to B, his velocity was 60 km and coming back his velocity was 40 km. So what are the total average velocity and average speed? Okay. So let's suppose the distance between two stations is x. Let's suppose the distance between two stations is what? X. Okay. So what are the formula for average? We know the formula. V average is equal to, you better know, x1 plus x2 upon x1 plus x2, and total time from A to B and then from B to A. So what are total time? T1 plus T2, already taught. This is the formula for average velocity, x1 plus x2 plus x3 plus 1 divided by T1 plus T2 plus T3 plus 1. Okay. So what are V average? We are talking about velocity. x1, A to B, what are distance? X plus, he is coming back. So what will get? So first we are getting speed. So this is the speed. Let's suppose speed. First we are getting speed. So he is coming back again by x distance divided by what a time? You better know. Velocity is equal to distance upon time. So what a time? Time is equal to distance upon velocity. Already we define this formula. So what a time? T1. T1 is equal to distance. How much distance from A to B? That distance is what? X upon what are the velocity? 60. This is the time T1. And what are the velocity for second? T2. He is coming back. So again x distance upon velocity is 40. So T1, T2 is better defined. A to B distance is x and velocity is 60. So time is equal to distance upon velocity x upon 60, and T2 is equal to x upon 40. This is the deduction of T1 and T2. So we will use here speed is equal to, you better know what is speed. Speed is equal to distance upon time. So what are distance? X plus x plus x divided by T1. What are T1? X upon 60 plus x upon 40. Okay. It will be 2x, x plus x, 2x divided by x is common. We will get 1 upon 60 plus 1 upon 40. X will cancel out. LCM will be what LCM? 60 into 40. They will go up. So we get 2 into 60 into 40 divided by here 40 plus 60. You will get what? 100. 2 0 will cancel out, and we will get 48 km per hour. So this is the speed. If you combine, let's suppose you are using this V1 plus V2 upon 2, you will get 60 plus 40, 100 upon 2 is equal to 50. See there, this is wrong answer. Here you are getting 48. Here you will directly what? 50. So don't go through that method. Okay, this is wrong method. Okay, so your average speed, this is the average. Your average speed will be what? 48 km per hour. Are you getting the A to B x1, B to A again x2, because both distances are same. So it will be x plus x upon T1 plus T2. T1, T2 we deducted here. If we put the value, we will get 48 km per hour. This is speed. What are the velocity? What is the velocity? You better know. Velocity is equal to displacement upon time. And already I taught what are the displacement. He went x kilometer and again back by x kilometer. So what are velocity is equal to? Velocity is equal to what are displacement? You better know, 0. X, so he went from A to B and again back to A. So its displacement becomes 0 upon T1 plus T2. So velocity is equal to what? 0. This is a very, very important point. So his speed was 48 km per hour, because speed is equal to distance upon time, and total travel distance x plus x, 2x, we are getting 2x, while velocity is equal to displacement upon time, so it will be 0 upon t1 plus t2, and velocity becomes 0. So this is first numerical based on average speed and average velocity. One more numerical we will take, and it is from your NCERT book. It is from your NCERT book. You search there. Question is here. Joseph jogs from A to B in a straight 300 meter. Joseph went from A to B, and it takes how much meter? What? 300 meter. This is given in your NCERT book. Okay, and he takes 2 minutes 30 seconds total time. Time is equal to, is given 2 minutes plus 30 seconds. So it will be time is equal to 2 minutes means 120 seconds. It means 120 plus 30. It minute converted into second, and 30 seconds. So total time taken by him is equal to 150 minute, 150 what second. That is the total time. Okay, he went from A to B and taken time 150 second. Okay, that is given. Okay, and around the 100 meter back to C, again he back by 100 meter. He back 100 meter at C. He went A to B by 300 meter, and back from B to C by how much meter? What? 100 meter. Okay. In 1 minute, that time is given 1. That was the T2, and that time T2, T1, and it time it takes how much minute? What? 100, 1 minute. It is 1 minute. It means 1 minute is equal to 60 watt, second. Okay. Now find what is the Joseph average speed in A to B and A to C. Joseph average speed and average velocity from A to B and A to C. Okay, now see there. First, speed. First we are talking from A to B. Speed is equal to, you better know distance. What is distance A to B? 300 upon time taken from A to B. It will be 150. So its answer will be what? Its answer will be, it become 2 meter per second. Speed is equal to 50 to the 2 meter per second. And similarly velocity. Velocity is equal to same thing, because A to B displacement is already 300 and time is same. So it will come again 300 upon 150 is equal to again 2 meter per second. Both is the same answer. Okay. If he back from B to C, then what will the total? He went from A to B and again back from B to C. So and it takes how much second? What? 60. So that was 150. It becomes 60. So again from A to B and from B to what? C. That is the trick. Speed is equal to distance. How much distance he traveled? 300 again back 100. So it become 400 upon how much time taken? 150 plus 60. It become 210. You calculate it, cancel out. It become 40 upon 21 meter per second. Okay, this is the speed. What is the velocity? Velocity is equal to displacement upon time. What a total displacement? He went from A to B 300 and back by 100. So it become total displacement become 200. So it become 200 divided by time. How much time total taken by him? 150 plus 60. So it become 200 what? 10. Cancel out. You will get 20 upon 21 meter per second. Okay. So this is the average speed and average velocity. Once again, he went from A to B. Speed and velocity was same. When he back at C 100 meter back, then it become distance become 300 plus 100. No, now you better know displacement never negative. It is always positive. So total become 300 plus 100. It become 400 divided by total time 150 plus 60. He is taking T2 time, and T2 is given how much? 1 minute. That is 60 seconds. So it will become 150 plus 60 become 210. So it become 40 upon 21. Velocity you better know displacement. That is the displacement. This is the shortest distance because he is now at C. So it become 200 upon 210. So it's equal to 20 upon 21 meter per second. Okay. So that's all for today. Next day we will study about acceleration. Okay, that's all.